alternate angles. So the first thing we need to do is ask ourselves, what are alternate angles? Alternate angles are a pair of angles formed on opposite sides of a transverse line when it intersects two parallel lines. So I'm going to write it down and then we'll draw the diagram. So I like to write the definition or explanation of a term before we start learning about it. So alternate angles are a pair of angles formed on opposite sides of a transverse line when it intersects two parallel lines. Okay, so let's draw. So these are two lines. They are parallel lines. How do we know they are parallel lines? To know parallel lines, you're going to see something like this. Okay, so these signs show that the lines in question are parallel lines. Then you have a line like this. This line is a transverse line. So if you look at the line, it is not vertical, it is slanting. If the line is not slanting, if it is vertical, it's not a transverse line. So for us to work with alternate angles, we must be working with transverse line, not vertical line, transverse line. Okay. So these two lines are parallel lines, which means they cannot meet. They have a constant distance between them. Okay. The distance at this point is the same as the distance between them at this point, so they cannot meet. Okay. So now, alternate angles are a pair of angles formed on opposite sides of a transverse line. So if you look at this transverse line, if you have an angle here, let's call it A, and we have an angle here, let's call it B. These two angles are alternate angles because they are on opposite sides. This one is facing this way, this one is facing this way. This one is facing this way and is down. This one is facing this way and it's up. Okay, so they form something like this, a Z. So you can see that they form a Z. Okay, so these two angles are alternate angles. So if you look at this line, they form something like this. So here you have A and here you have B. So this is a transverse line that cuts through these parallel lines. So they form this Z. So A and B are alternate angles. So we have identified a pair of alternate angles. A and B are alternate angles. Let's see another pair of alternate angles. If you have this side, we call it C, and we have this side, we call it D. C and D are also alternate angles. If you look at this, they form something that looks like a Z. It also looks like a Z, but it looks as if it is stretched. So this angle here and this angle here, they are also alternate angles. Okay? So whenever you see angles like this, A and B or C and D, they are alternate angles. And the principle states that alternate angles are equal to each other. Alternate angles are equal to each other. So let's write the principle. So whenever you identify two alternate angles or a pair of alternate angles, always remember that those angles are equal to each other. So, but before we continue, I'm going to write some other angles and let's see if we can identify this G. Let's call this E. Let's call this F, and let's call this H. I just want us to step back a little. Can you identify at least one vertically opposite angles in each of these situations? Can you identify vertically opposite angles here? Just name one pair of angles that are vertically opposite. E and F. E is over here, F is over here. Are they vertically opposite? Vertically opposite angles meet at a particular point, right? Somebody say A and B. A and B are alternate. G and H. Oh, can you see the reason I asked the question? The reason I asked the question is correct. Somebody got an answer. A and G are vertically opposite. They must share the same intersection. So if you say G and H, they are not sharing the same intersection, right? A and C, nope. B, correct. So B and H are vertically opposite. They can only be vertically opposite if they are sharing the same intersection point, right? D and F, correct. D and F are vertically opposite. Good. So I just wanted to make sure of that. Okay. So when you have a situation like this, you cannot pick an angle here, pick an angle here, and say they are vertically opposite. They are not sharing the same intersection point. H and B. Okay, good. So now let's look at examples under alternate angles. Okay, so now we need to find the values of x, y, and z in this particular diagram. So just remembering the principles that we've learned can help you find the value of x. So what principle are we going to use to find the value of x? Alternate. So, opposite angles. Vertically opposite angles to get the value of x. If you look at the value of x and 110, they look like this, right? So this is 110, this is x. So they are alternate angles, right? So alternate angles are equal to each other. That means if this is 110, x is equal to 110. Okay. So we've gotten the value of x. To get the value of y, what principle are we going to use? What principle are we going to obey? Though we didn't learn it in this particular class, but we have applied it in this particular class today. What the principle that will help us to get y has been applied in today's class, though it's not among the two principles we have learned today. Angles on a straight line, correct. So if you look at this is a straight line, and at this point, these two angles are on this straight line. So we solve the equation where we say sum of angles on a straight line is equal to 180 degrees. That means x plus y is equal to 180 degrees. So x plus y is equal to 180 degrees. Angles on a straight line. So we know that x is already equal to 110 degrees. So we can simply say y is equal to 180 degrees minus 110 degrees. Y is equal to 70 degrees. So the value of y is equal to 70 degrees. So we've gotten the value of y to be 70 degrees. What will be the value of z? And what principle are we going to apply to get z? Vertically opposite angles, correct. So x and z are vertically opposite, and vertically opposite angles are equal. That means z is equal to 110 degrees. So we're going to look at another question. So we're expected to find the value of x in this diagram we have here. Looking at these two angles, this angle here and this angle here, we can clearly identify them as alternate angles. And we know that alternate angles are equal. That means 7x minus 20 is equal to 4x plus 10. Okay. So for us to get the value of x, we have to move 4x to the left. It becomes a minus. We have to move minus 20 to the right. It becomes a plus. Seven x minus 4x gives us 3x. 10 degrees plus 20 degrees gives us 30 degrees. So dividing both sides by 3. x is equal to 10 degrees. So that gives us the value of x. So now I'm going to write down the question for today. The last topic we learned is alternate angles. So the key to solving this question is alternate angles. That's the first step you need to apply, alternate angles.